So fault takes place in any of the feeders or downstream, right, of a transformer, then all the fault current will flow through the transformer. So the transformer also gets subjected to abnormal situation. Right? What happens is, really, with the large current flowing in the transformer, it is not only the heating that takes place, you know that actually I2R heating which takes place there. In addition to that, actually when in the winding, when those large currents flow, the most difficult thing is that the tenuous thing is really the mechanical forces caused by the current. Okay? So those mechanical forces can really shape the winding, right? And there is the flow can collapse. It's happening, right? But anyway, really when the transformers are designed, so all that are looked after. So it's very rare because those conditions, because when you know the maximum power level condition, right? You know the maximum power current that has to go through the transformer, and with that you know really what sort of mechanical forces which will be subjected, and because of that they will be able to design the transformer into those conditions. Okay. Then the overvoltage, right? There can be now actually recently the fault that took place recently they are called voltage. We know that actually the news written is right now reading the papers, really the fault was on the catalytic and column heavy line, the conductor had come down, was down, right? So the fault current has been flowing from both directions. Okay? So really the transformer on both sides would have got really set at the beginning with the fault current, right? With the fault current, and it persisted for a reasonable time, and because that is subject to the mechanical status, but fortunately the transformer are failed because really those have been designed to withstand such current. Okay? So that is important. So look at the short time rating for the transformer and to ensure that those are designed and manufactured according to the needs. Yeah. Then the overvoltage, right? There can be transient overvoltage. We know that actually we have long transmission lines, so this is long or short, and there can be lightning. And I'm sure that you already have studied on in the high voltage, right? About the surge voltage is traveling up and down, the reflection also, and really the voltage is concentrating on one point and subjecting the transformer or whatever it is to very high voltage setting. So actually when transformers are also exposed. Then also the power frequency of voltages, again in this area you will see that I don't know how many of them are off that point of 230. Then they were trying to really energize the system. Right? What happens is really they normally switch off all the big substation loads and try to energize one big substation by one big substation. Then what happens is, without load, what will be the load? It will be more or less capacity. When you have a capacity load, what will be the sending input or receiving input? It would shoot up. Right? So it's again very bad for all these systems, not only for the capacitor, right? Not only for the transformer, all these systems are dead. And even the transformers also coming to that category. Okay? So it will increase the stress on the insulation, and also now we know that actually when the voltage is applied onto a inductor, there is a certain flux. So the flux, because with the higher voltage, what happens is the flux increases, and there's the possibility for the really large eddy current and all that forming around the board that connects the iron core. You get boards fitted there, insulated boards. Okay, insulated boards. So actually, in those events, it is possible for the eddy current and pick that those persist for a long period, and if the currents are high, really the bolt will melt, right? And really the core can get damaged. Okay, so and then really the iron loss also increases, and the junction system frequency is equivalent to the voltage, because actually it drops the impedance, really the impedance gets lower, delta W, right? So with that similar bad effects too. Then also, as far as the transformer uses for those are external conditions, such as there is a V-shaped overloading, okay, right? Okay, overloading, we know the system fault, okay, over voltages, and there is a reduction in frequency. Okay. As far as the internal faults of the transformer are concerned, am I too fast, or do you want me to slow down? Yeah? Okay, so these are just normal stuff, right? So that you are familiar. So as far as the transformers are concerned, we know that actually there can be 2-winding transformers, 3-winding transformers, right? Like that. So you get a winding there. And these windings can really develop fault. It can be really phase of fault because insulation is provided, or real phase towards or something like that, or internal fault. Those are possible. Okay. So those are the possibilities. Third fault is there, it will depend on the system, so all those are there. So having looked at what sort of problems in the transformers will face, now we will see how really what are the principles we have to employ to protect the transformer from all the types of faults that we have been discussing just a few seconds. Right? Now the first one is we saw that as overloading. Right? So with the overload, what happens is the transformer is overloaded. Right? So the temperature goes up. Right? So that is one principle that we have to apply in really detecting transformer overload, right? Then we saw the system fault. Okay, with the system fault, we know that actually all the system faults will be either will create a fault condition or the overcurrent condition. Okay, so we have to employ overcurrent and fault protection to protect the transformer for that. Okay. Then we saw that actually there will be winding faults and extended. There we will have to employ a new type of protection as far as we are concerned, because we haven't gone into that public testing. That is the differential. Differential is nothing really new to you all. Anybody will know what is going in if some system is healthy, would come out as the other thing. Right? So we are comparing the in and out, right? And if there is a difference, we know that there is some problem, and that is then we say that actually the transformers are filled with soil, and we know that actually if there is a problem or there is some sort of overheat in the transformer, right, what will happen? The oil will get decomposed. Right? When the oil gets decomposed, there will be a gas, and that the gas will try to escape. And we use that as a ploy to see whether the transformers are having any internal problem. Okay. Then the overfluxing means really, we said that actually the transformers cannot really, working transformers really using transformers at voltage is higher than normal could cause certain dangers, and also really with the lower frequency we have again the same situation. But the transformer will be able to work at a little higher voltage and a little higher frequency. Okay. So what we really look at is the flux. So we look at the V upon S ratio, right? So that when the V upon S is equal or less than 1, in the sense, I mean, if you take the perimeter, then it is okay. So the if V also go up and S also goes up, we can really the transformer doesn't get damaged or it doesn't lose its life. And so these are the basic principles with which we are